on the topic of like discovery of evidence of alien civilizations, which is something you touch on in your book, what that idea would do to societies, to the human psyche, and in general, do you think? And you talk about the, I still have trouble pronouncing, but
Oumuamua.
Oumuamua wager,
Mhm.
right? What do you think is? Can you explain it? And what do you think in general is the effect that such knowledge might have on human civilization?
Right. So Pascal had this wager about God. And by the way, there are interesting connections between theology and the search for extraterrestrial life. It's possible that, we were planted on this planet by another civilization. That,
Yes.
We attribute to God powers that belong really to technological civilization. But putting that aside, Pascal basically said, there are two possibilities: either God exists or not, right?
Mm-hmm.
And if God exists, the consequences are quite significant, and therefore, we should consider that possibility differently than equal weight to both possibilities.
Yes.
And I suggest that we do the same with Oumuamua or other technological signatures, that we keep in mind the consequences and therefore pay more attention to that possibility. Now, some people say extraordinary claims require extraordinary evidence. My point is that the term extraordinary is really subjective. For one person, a black hole is extraordinary. For another, it's just a consequence of Einstein's theory of gravity. It's nothing extraordinary.
Yeah.
The same about the type of dark matter, anything. So we should leave the extraordinary part of that sentence. Just keep evidence, okay? So let's be guided by evidence. And even if we have extraordinary claims, let's not dismiss them because the evidence is not extraordinary enough. Because if we have an image of something and it looks really strange and we say, oh, the image is not sufficiently sharp, therefore we should not even pay attention to this image or not even consider. I think that's a mistake.
Yes.
What we should do is say, look, there is some evidence for something unusual. Let's try and build instruments that will give us a better image. And if you just dismiss extraordinary claims because you consider them extraordinary, you avoid discovering things that you haven't expected. And so I believe that along the history of astronomy, there are many missed opportunities. And I speak about astronomy, but I'm sure in other fields it's also true. I mean, this is my expertise. For example, the Astrophysical Journal, which is the main primary publication in astrophysics, if you go before the 1980s, there are images that were posted in the Astrophysical Journal of giant arcs, arcs of light surrounding clusters of galaxies. And, you can find it in printed versions of the Astrophysical Journal. People just ignore. They put the image, they see the arc, they say, who knows what it is, and just ignore it. And then in the 1980s, the subject of gravitational lensing became popular.
Mm-hmm.
And the idea is that you can deflect light by the force of gravity. And then you can put a source behind the cluster of galaxies, and then you will get these arcs. And actually, Einstein predicted it in 1940. And, so these things were expected, but people just had them in the images, didn't pay attention. So I'm sure there are lost opportunities sometimes. Even in existing data, you have things that are unusual and exceptional, and are not being addressed.
Yeah, you actually, I think you have the article, the data is not enough from quite a few years ago, with where you talk with, we can go back to the 70s and 80s, but we can go also to the Mayan civilization.
Right. The Mayan civilization basically believed in astrology that you can forecast the outcome of a war based on the position of the planets.
Yes.
And they had, astronomers in their culture had the highest social status. They were priests.
Yes.
They were elevated. And the reason was that they helped politicians decide when to go to war. Because they would tell the politicians, the planets would be in this configuration. It's a better chance for you to win the war.
Yes.
Go to war. And in retrospect, they collected wonderful data but misinterpreted it. Because we now know that the position of Venus or Jupiter or whatever has nothing to do with the outcome of World War I or World War II. It has nothing to do. And so we can have a prejudice and collect data without actually doing the right thing with it.
That's such a Pisces thing to say. I looked up what your astrological sign is. So, so you mentioned Einstein predicted that black holes don't exist, or just did, or thought
don't exist in nature.
Don't exist in nature.
When Einstein came up with his theory of gravity in 1915, November 1915, a few months later, another physicist, Karl Schwarzschild, he was the director of the Potsdam Observatory, but he was a patriot, a German patriot. So he went into the First World War fighting for Germany. But while he was at the front, he sent a postcard to Einstein saying, a few months after the theory was developed, saying, actually, I found a solution to your equations. And that was a black hole solution. And then he died a few months later. And Einstein was a pacifist, and he survived. So the lesson from this story is that if you want to work out the consequences of a theory, you better be a pacifist. But the point is that this solution was known shortly after Einstein came up with his theory. But in 1939, Einstein wrote a paper in the Annals of Mathematics saying, even though the solution exists, I don't think it's realized in nature. And his argument was, if you imagine a star collapsing, stars often spin, and the spin will prevent them from making a black hole, collapsing to a point.
So, I mean, can you maybe, one of the many things you have work on, you're an expert in, is black holes. Can you first say, what are black holes? And second, how do we know that they exist?
Right. So black holes are the ultimate prison. You can check in, but you can never check out. Even light cannot escape from them. So there are extreme structures of space and time. And there is this so-called Schwarzschild radius or the event horizon of a black hole. Once you enter into it with a spaceship, you would never be able to tweet back to your friends and tell them. By the way, I asked the students in my class, freshman seminar at Harvard, I said, let me give you two possible journeys that you can take. I said, suppose aliens come to Earth and suggest that you would board their spaceship. Would you do it? And the second is, suppose you could board a spaceship that will take you into a black hole. Would you do it? So all of them said to the first question, yes, under one condition, that I'll be able to maintain my social media contacts and report back, share the experience with them. I couldn't, but personally, I have no footprint on social media.
Yeah, which is as a matter of principle.
Yeah, my wife asked me when we got married, and I honor that.
And I told you offline, I need to get married to such a woman. She truly is a special lady.
Well, she was wise enough to recognize the risk, but it saves me time, and it also keeps me away from crowds. I don't have the notion of what a lot of other people think, so I can think independently.
Think, exactly.
Yeah, exactly. But I was surprised to hear that for students, it's extremely important to share experiences. Even if they go on a spaceship with aliens, they still want to brag about it rather than look around and see what's going on.
This is not an option when you go to the black hole. It's exactly the point.
So for the black hole, they said no, because obviously you can find your death after you get into it. You crash in the singularity. There is this singularity in the center. So inside the event horizon, we know that all the matter collects at a point. Now, we can't really predict what happens at the singularity because Einstein's theory breaks down. And we know why it breaks down, because it doesn't have quantum mechanics that talks about small distances. We don't have a theory that unifies quantum mechanics and gravity so that it will predict what happens near a singularity. And in fact, I once, a couple of years ago, I had a flood in my basement. I mean, and I invited a plumber to come over and figure out, and we found that the sewer was clogged because of tree roots that got into it. And we solved the problem. But then I thought to myself, well, isn't that what happens at the singularity of a black hole? Because the question is, where does the matter go? If in the case of a home, I never thought about it, but
Yes.
the water, all the water that we use, goes in, through the sewer to some reservoir somewhere. And the question is, what happens inside a black hole? And one possibility is that there is an object in the middle, just like a star, and everything collects there. And the object has the maximum density that we can imagine, like Planck density. It's the ultimate density that you can have, where gravity is as strong as all the other forces. So you can imagine this object, very dense object at the center that collects all the matter. Another possibility is that there is some tunnel, just like the sewer. It takes the matter into another place. And we don't know the answer. But I wrote a Scientific American essay about it, and admitting our ignorance. So it's a fascinating question. What happens to the matter that goes into a black hole? I actually recommended to some of my colleagues that work on string theory, at the closing of a conference. I'm the founding director of the Black Hole Initiative at Harvard, which brings together astronomers, physicists, philosophers, and mathematicians. And we have a conference once a year. And at the end of one of them, since I'm the director, I had to summarize. And I said that I wish we could go on a field trip to a black hole nearby. And I highly recommend to my colleagues that work on string theory to enter into that black hole, because then they can test their theory when they get inside. But one of the string theorists in the audience, Nimar Kani Hamed, immediately raised his voice and said, "You have an ulterior motive for sending us into a black hole," which I didn't deny, but at any event.
Yeah, that's true. That's true. Can you say why we know that black holes exist?
Right. So it's an interesting question, because black holes were considered a theoretical construct. And Einstein even denied their existence in 1939. But then in the mid-1960s, quasars were discovered. These are very bright sources of light, 100 times brighter than their host galaxy, which are point-like at the center of galaxies. And it was immediately suggested by Ed Salpeter in the West and by Yakov Zeldovich in the East that these are black holes that accrete gas, collect gas from their host galaxy, that are being fed with gas. And they shine very brightly because as the gas falls towards the black holes, just like water, running down the sink, the gas swirls and then rubs against itself and heats up and shines very brightly because it's very hot close to the black hole. By viscosity, it heats up. And in the case of black holes, it's the turbulent viscosity that causes it to heat up. So we get these very bright sources of light just from black holes that are supposed to be dark. Nothing escapes from them, but they create a violent environment where gas moves close to the speed of light and therefore shines very brightly, much more than any other source in the sky. And we can see these quasars all the way to the edge of the universe. So we have evidence now that when the universe was, about 7% of its present age, infant,
Yes.
Already back then you had black holes of 1 billion times the mass of the sun, which is quite remarkable. It's like finding giant babies in a nursery. How can these black holes grow so fast? Less than 1 billion years after the Big Bang, you already have 1 billion times the mass of the sun in these black holes. And the answer is presumably there are very quick processes that build them up.
They build quickly.
Very quickly. And so we see those black holes, and that was found in the mid-1960s. But in 2015, exactly 100 years after Einstein came up with his theory of gravity, the LIGO Observatory detected gravitational waves. And these are just ripples in space and time. So according to Einstein's theory, the innovation, the ingenuity of Einstein's theory of gravity, that was formulated in November 1915 was to say that space and time are not rigid. They respond to matter.
Mm-hmm.
So, for example, if you have two black holes and they collide, it's just like a stone being thrown on a surface of a pond. They generate waves, disturbances in space and time that propagate out at the speed of light. These are gravitational waves. They create a space-time storm around them, and then the waves go all the way through the universe and reach us. And if you have a sensitive enough detector like LIGO, you can detect these waves. And so it was not just the message that we received for the first time, gravitational waves, but it was the messenger. So there are two aspects to it. One is the messenger, which is gravitational wave, for the first time were detected directly. And the second was the message, which was a collision of two black holes, because we could see the pattern of the ripples in space and time, and it was fully consistent with the prediction that Schwarzschild made for how the space-time around the black hole is, because when two black holes collide, you can sort of map from the message that you get, you can reconstruct what really happened, and it's fully consistent.
And in 2017 and 2020, there's two Nobel Prizes.
That's right.
That had to do with the black holes. Can you maybe describe in the same masterful way that you've already been doing what those Nobel Prizes were given for?
Yeah, so the 2017 was given for the LIGO collaboration for discovering gravitational waves from collisions of black holes. And the 2020 Nobel Prize in Physics was given for two things. One was theoretical work that was done by Roger Penrose in the 1960s, demonstrating that black holes are inevitable when stars collapse.
Mm-hmm.
And it was mostly mathematical work. And actually, Stephen Hawking also contributed significantly to that frontier. And unfortunately, he is not alive, so he could not be honored. So Penrose received it on his own. And then two other astronomers received it as well, Andrea Ghez and Reinhard Genzel, and they provided conclusive evidence that there is a black hole at the center of the Milky Way galaxy that weighs about 4 million times the mass of the sun. And they found the evidence from the motion of stars very close to the black hole. Just like we see the planets moving around the sun, there are stars close to the center of the galaxy, and they are orbiting at very high speeds of order thousands of kilometers per second or thousands of miles per second. Think about it.
Yeah.
Which can only be induced at those distances if there is a 4 million solar mass object that is extremely compact. And the only thing that is compatible with the constraints is a black hole. And they actually made a movie of the motion of these stars around the center. One of them moves around the center over a decade, 60, over timescales that we can monitor. Mm-hmm. And it was a breakthrough in a way. So combining LIGO with the detection of a black hole at the center of the Milky Way and in many other galaxies like quasars, now I would say black hole research is vogue. It's very much in fashion. We saw it back in 2016 when we established the Black Hole Initiative.
Yes, you kind of saw that there's this excitement about in breakthroughs and discoveries around black holes, which are probably one of the most fascinating objects in the universe. I mean, it's up there. Right. They're both terrifying and beautiful, right? And they capture the entirety of the physics that we know about this universe.
I should say, the question is, where is the nearest black hole? Can we visit it? I wrote a paper with my undergraduate student, Amir Siraj, suggesting that perhaps, there could be, if there is one in the solar system, we can detect it. Because I don't know if you heard, but there is a claim that maybe there is a planet 9 in the solar system. because we see some anomalies at the outer parts of the solar system. So some people suggested maybe there is a planet out there that was not yet detected. So people searched for it, didn't find it. It weighs roughly 5 times the mass of the Earth. And we said, okay, maybe you can't find it because it's a black hole that was formed early in the universe.
Is that so? Where do you stand on that?
It could be that the dark matter is made of black holes of this mass. We don't know what the dark matter is made of. It could be black holes. So we said, but there is an experimental way to test it, and the way to do it is because there is the Oort cloud of icy rocks in the outer solar system, and if you imagine a black hole there. Every now and then a rock will pass close enough to the black hole to be disrupted by the very strong gravity close to the black hole, and that would produce a flare that you can observe. And we calculated how frequently these flares should occur. And with LSST on the Vera Rubin Observatory, we found that you can actually test this hypothesis.
That's brilliant.
And if you don't see flares, then you can put limits on the existence of a black hole in the solar system. It would be extremely exciting if there was a black hole, if Planet 9 was a black hole, because we could visit it, and we can examine it.
Yeah.
And it will not be a matter of, an object that is very removed from us. Another thing I should say is, it's possible that a black hole affected life on Earth. The black hole at the center of the Milky Way. How? That black hole right now is dormant. It's very faint.
Mm-hmm.
But we know that it flares. When a star like the sun comes close to it, the star will be spaghettified, basically become a stream of gas, like a spaghetti. And then the gas would fall into the black hole and there would be a flare. And this process happens once every 10,000 years or so. So we expect that, these flares to occur every 10,000 years. But we also see evidence for the possibility that gas clouds were disrupted by the black hole, because the stars that are close to the black hole are residing in a single or two planes. And the only way you can get that is if they formed out of a disk of gas, just like the planets in the solar system formed. So there is evidence that gas fell into the black hole and powered possibly a flare. And these flares produce X-rays and ultraviolet radiation that could damage life if the Earth was close enough to the center of the galaxy. Where we are right now, it's not very risky for us. But there is a theoretical argument that says the solar system, the sun, was closer to the galactic center early on, and then it migrated outwards.
Oh, interesting.
So maybe in the early stage of the solar system, the conditions were affected, shaped by these flares of the black hole at the center of the galaxy. And that's why for the first 2 billion years, there wasn't any oxygen in the atmosphere, who knows. But it's just interesting to think that, from a theoretical concept that Einstein resisted in 1939, it may well be that, black holes have influence on our life. And that, it's just like discovering that some stranger affected your family and in a way your life. And if that happens to be the case, a second Nobel Prize should be given, not for just the discovery of this black hole at the center of the galaxy, but perhaps for the Nobel Prize in chemistry, for the effect that it had
on life, for the interplay that resulted in some kind of the chemical effect, biology, all those kinds of things in terms of the emergence of life and the creation of a habitable environment. That's so fascinating. And of course, like you said, dark matter, like black holes have something.
They could be the dark matter in principle, yes. We don't know what the dark matter is at the moment.
Does it make you sad? So you've had an interaction and perhaps a bit of a friendship with Stephen Hawking. Does it make you sad that he didn't win the Nobel?
Well, altogether, I don't assign great importance to prizes, because,
as you said,
Jean-Paul Sartre, who I admired as a teenager, because I was interested in philosophy. When I grew up on a farm in Israel, I used to collect eggs every afternoon, and I would drive the tractor to the hills of our village and just think about philosophy, read philosophy books. And Jean-Paul Sartre was one of my favorite. And he was honored with the Nobel Prize in Literature. He was a philosopher primarily, existentialist. And he said, the hell with it. Why should I give special attention to this committee of people that get their self-importance from awarding me the prize? Like,
Yes.
what's why does that merit my attention?
Yes.
So he gave up on the Nobel Prize. And there are two benefits to that. One, that you're not working your entire life in the direction that would satisfy the will of other people. You work independently. You're not after these honors. Just for the same reason that if you're not living your life for making a profit or money, you can live a more fulfilling life because you're not being swayed by the wind, of how to make money and so forth. The second aspect of it is, that very often, these prizes, they distort the way we do science, because instead of people willing to take risks, and instead of having announcements only after a group of people converges with a definite result, the natural progression of science is based on trial and error, so reporting some results, and perhaps they're wrong, but then other people find perhaps better evidence, and then you figure out what's going on. And that's the natural way that science is, it's a learning experience. Yeah. So if you give the public an image by which scientists are always right, and some of my colleagues say we must do that, because otherwise the public will never believe us that global warming is really taking place.
Right.
But that's not true, because the public will really believe you if you show the evidence.
Yes.
So the point is, you should be sincere when the evidence is not absolutely clear, or where there are disputes about the interpretation of the evidence. We should show ourselves. Yes. The king is naked. Okay, there is no point in pretending that the king is dressed.
Yes.
Saying that scientists are always right. Scientists are wrong.
Yes.
Frequently. Yes. And the only way to make progress is by evidence, giving us the support that we need to make airtight arguments. So when you say global warming is taking place, if the evidence is fully supportive, if there are no holes in the argument, then people will be convinced, because you're not trying to fool them. When the evidence was not complete, you also show them that the evidence is not complete.
Yeah, and when there's holes, you show that there's holes, and here's the methodology we're using to try to close those holes.
Exactly. Let's be sincere. Why pretend? So if there were in a world where there were no prizes, no honors, we would act like kids, as I said before. We would really be focusing on the ball and not on the audience.
Yeah, the prizes get in the way, and that's so powerful. Do you think, in some sense, the few people that have turned down the prize made a much more powerful statement? I don't know if you're familiar in the space of mathematics with the Fields Medal and Gregor Perelman, who turned down the prize. I've committed. One of the reasons I started this podcast is I'm going to definitely talk to Putin. I'm definitely talking to Perelman, and people keep telling me it's impossible. I love hearing that, because I'll talk to both. Anyway, but do you have a sense of why he turned down the prize, and is that a powerful statement to you?
Well, what I read is that you're talking about the mathematician.
The mathematician turned down the
what I read is that he was disappointed by the response of the community, the mainstream community, the mathematicians, to his earlier work, where they dismissed it. They didn't attend to the details and didn't treat him with proper respect, because he was not considered one of them.
Yes.
And I think that speaks volumes about the current scientific culture, which is based on groupthink and on social interaction, rather than on the merit of the argument and on the evidence in the context of physics. So in mathematics, there is no empirical base. You're exploring ideas that are logically consistent. But nevertheless, there is this groupthink. And I think he was so frustrated with his past experience that he didn't even bother to publish his papers. He just posted them on the archive. And in a way, it's saying, I know what the answer is. Go look at it.
And then again, in the long arc of history, his work on archive will be remembered, and all the prizes, most of the prizes will be forgotten. That's what people don't kind of think about. Is when you look at Roger Penrose, for example, is another fascinating figure. It's possible, and I forgive me if it's, I'm sure, my ignorance, but he's also did some work on consciousness. He's been one of the only people who spoke about consciousness, which for the longest time and is still arguably outside of the realm of the sciences.
Right.
It's still seen as a taboo subject. And he was brave enough to explore it from a physics perspective, from just a philosophical perspective, but like with the rigor, like proposing different kind of hypotheses of how consciousness might be able to emerge in the brain. And it's possible that that is the thing he's remembered for if you look 100 years from now, right? As opposed to the work in the black holes, which fits into the kind of fits into what the current scientific community allows to be the space of what is and isn't science.
Yeah, it's really interesting to look at people that are innovators, where in some phases of their career, their ideas fit into the social structure that is around them, but in other phases, it doesn't. And when you look at them, they just operated the same way throughout. And it says more about their environment than about them.
Well, yeah, I don't know if you know who Max Tegmark is.
Yes,
I just recently talked to him.
He's a friend of mine.
I just recently talked to him again, and he was a little bit more explicit about saying, being aware, which is something I also recommend, is like being aware where the scientific community stands and doing enough to move along into your career. And yeah, it's the necessary evil, I suppose. If you are one of those out of the box thinkers that just naturally have this childlike curiosity, which Max definitely is one of them, is sometimes you have to do some stuff that fits in, you publish and you get tenure and all those kinds of things.
But the tenure is a great privilege because it allows you to, in principle, explore things that are not accepted by others. And unfortunately, it's not being taken advantage of by most people. And it's a waste of a very precious resource.
Yeah, absolutely. Well, you're one of the most respected, famous scientists in the world, sitting on a farm, gazing up at the stars. So you seem like an appropriate person to ask the completely inappropriate question of, what do you think is the meaning of it all? What's the meaning of life?
That's an excellent question. And if we ever find an alien that we can converse with, I would like to answer this. I would like to ask for an answer to this question because
would they have a different opinion, you think?
Well, they might be wiser because they lived around for a while, but I'm afraid they will be silent. I'm afraid they will not have a good answer. And I think it's the process that you should get satisfied by, the process of learning you should enjoy. Okay, so it's not so much that there is a meaning. In fact, there is, as far as I can tell, things just exist, and it's. I think it's inappropriate for us to assign meaning for our existence because, we, as a civilization, we will eventually perish, and nothing will be, just another planet on which life died, and if you look at the big scheme of things, who cares? Who cares? And how can we assign significance to what we are doing? So if you say the meaning of life is this, well, it will not be around in 1 billion years. So what, it cannot be the meaning of life because life, nothing will be around. So I think we should just enjoy the process. And, it's like many other things in life. You enjoy good food. Okay.
Yeah.
And you can enjoy learning. Why? Because it makes you appreciate better the environment that you live in. And sometimes people think religion, for example, is in conflict with science, spirituality in conflict. That's not true. if you see a watch and you look at it from the outside, you might say, oh, that's interesting. But then if you start to open it up and learn about how it works, you appreciate it more. So science is the way to learn about how the world works. And it's not in conflict to the meaning that you assign to all of this, but it helps you appreciate the world better. So in fact, I would think that a religious person should promote science because it gives you a better appreciation of what's around you. It's like, if you buy in a grocery, you buy something, a bunch of fruits that are packed together, and you can't see from the outside exactly what kind of fruits are inside. But if you open it up and study, you appreciate better the merchandise that you get, right? So you pay the same amount of money, but at least you know what's inside. So why don't we figure out what the world is about, what the universe contains, what is the dark matter? It will help us appreciate, the bigger picture. And then you can assign your own flavor to what it means,
Avi, I think I'm truly grateful that a person like you exists at the center of the scientific community. It gives me faith and hope about this this big journey that we call science. So thank you for writing the book you wrote recently. You have many other books and articles that I think people should definitely read. And thank you for wasting all this time with me. It was truly an honor. Thank you so much.
It was not a waste at all. And thank you for having me. I learned a lot from your questions and your remarks. Thank you.
Thank you.
Ground control to Major Tom. 7, 6. Commencing countdown, engines on. 3, 2. Check ignition, and may God's love be with you. This is ground control to Major Tom. You've really made the grade, and the papers want to know whose shirts you wear. Now it's time to leave the capsule if you dare. This is Major Tom to ground control. I'm stepping through the door, and I'm floating in a most peculiar way, and the stars look very different today. For here am I sitting in a tin can.
The Alpha Intergalactic Space Station has reached critical mass in orbit. Its weight and size now poses serious threat to Mother Earth. In its great wisdom, the Central Committee has decided to use all resources necessary to release the space station from the Earth's gravity. Its new course is set for the Magellan Current. Like the great explorer Magellan, the Alpha Station will journey into the unknown. A symbol of our values and knowledge, it will carry a message of peace and unity to the farthest reaches of the universe. Our thoughts and prayers go with you. Godspeed and good luck.